Hi, this is AJ Ragusa with the IU Global NOC Systems Engineering team. Today we're going to be demoing OESS 2.0 and its ability to do direct connect provisioning into Amazon. Stay tuned for more. Before we start the demo, I'd like to explain very quickly what you will see. The right side of this diagram shows everything that is pre-configured in Amazon. There is a virtual instance connected to a virtual private cloud, which is connected to a virtual private gateway, which is connected to a direct connect gateway that is already pre-configured. Our demo will be taking and creating a L3 VPN or a VRF on the Internet2 network and attaching that VRF via direct connect into the direct connect gateway that is already pre-configured. The left side of the diagram shows the setup inside of Indiana University. There's already a router which is pre-configured with BGP, so that way all that we have to do is configure the Internet2 L3 VPN for everything to start functioning. Let's go see the demo. This is the new OESS 2.0 web UI. You can see that we have no L3 VPNs currently, and so we're going to have to create a new L3 VPN. I'm going to title this VPN Demo to VRF to AWS, and then I'm going to add endpoints. You'll notice that our endpoint selection has changed, and now we select by entity. In this case, I'm going to select Indiana University. Once I've selected Indiana University, the available VLAN tags that go to Indiana University that I have access to show up. Once I've added the endpoint, I now have to configure the BGP sessions. Your ASN and your IP are the IP addresses of your device and the ASN of your device. The OESS IP is the IP address of what will be your remote peer, or the Internet2 configured IP address. I need to configure another interface for this L3 VPN to work. In this case, I want to select cloud providers, and then I can navigate to AWS, and then I'm going to look for US East Virginia, and then the hosted VIF interface. In this case, again, I'm going to select my VLAN. I'm required to enter a max bandwidth, and I also have to enter our AWS account ID. Once I've entered this in, I can hit Add Endpoint, and I will get the same BGP configuration screen that I had previously, with one exception. The Your ASN field is now not accessible to me because AWS is going to give me an ASN once I create this session. I also am required to set a BGP key. Once I'm done with this, I can click the plus button again to add it to my endpoint. Now that I'm done, I can quickly review, make sure that all settings look good, and then I can click Add L3 VPN. At this point, OESS is talking to both the Internet2 network and AWS. Once this is done, we'll be able to see our L3 VPN on the Internet2 network, as well as go into our AWS console to view the details of our hosted VIF interface. At this point in time, this VRF has been provisioned in OESS and inside of the Amazon cloud. Now that our L3 VPN is configured, we can take a look at the details. Specifically, at the bottom, we can see our endpoints and their BGP details. Specifically, we're going to take a look at the US East Virginia hosted VIF on AWS and notice that its ASN is 7224. This will be important later on once we go to approve it in the AWS console. We can also see the status of our BGP peers. Our graph should start updating within a minute of provisioning to show us the current number of active prefixes on both of the routers. All routers and their routing tables will show up. Once I log into the AWS console, I can see a list of all of my interfaces. Specifically, in this case, I'm looking for our demo VRF to AWS. And you can see, taking a look at the Amazon side ASN, is 7224. I'm going to approve this by clicking the Accept, and then selecting Direct Connect Gateway and the Direct Connect Gateway that was pre-configured. Once I click Accept, it will change the Amazon side ASN from 7224 to 6550. Now OESS will need to pick up this change. Additionally, AWS must now configure their side with VLAN 1005 and this ASN of 65500. When we come back to the OESS side, and we can take a look at our graph is updating, and we've now updated this page. And so now we will see the real-time data. We can see that the peering to Indiana University is up because my router did not need any additional configuration. Additionally, we can see that we've started a ping. This ping is trying to ping from a test box inside of Indiana University to a box inside of the Amazon cloud. Once our demo is complete, this should start working and be able to ping. But first, OESS will need to detect the change inside of AWS and then provision the change so that way we match all of the ASN, IP addresses, and anything else inside of the AWS side. The OESS 2.0 Web UI also includes several other details. The statistics page shows statistics related to your L3 VPN, specifically interface usage and BGP peer usage. We can take a look at each interface on our L3 VPN along with each BGP peer, in case you have multiple per interface, along with changing the time frames from day, week, year. We also have integrated in Router Proxy. The Commands tab will allow us to run commands on devices related to our L3 VPN and even specifically to interfaces. The run command will run whatever command it is on whichever switch is specified, and the results will be sanitized and displayed to the end user. This is very similar to the production Router Proxy we're used to today. Returning to the VRF details page, we can see that the active prefix count has gone to 0. This means that OESS detected the change and has removed and re-added the peerings. If we refresh the page, we'll be able to see a little bit more detail here. For example, we can see that the US East Virginia hosted VIF has changed from a ASN of 7224 to 65500, which is what we expected to see. This means that OESS detected the change and has updated it. We'll now expect for both of these peerings to become active over time. It just takes a few seconds for all of the BGP stuff to be reconfigured. For example, we'll load up a ping here. This is trying to ping from the test lab at Indiana University into the Amazon cloud. And so we will now have to wait for the Amazon side and all the BGP peerings to come up before we'll be able to actually see the successful ping. As you can see, our ping has now started working. This means that we have our L3 VPN properly configured in the Internet2 network. Our BGP sessions are up between Indiana University and the Internet2 network, as well as from Internet2 into the Amazon cloud. All of our routes are being shared, and so now we have full connectivity from the Indiana University test lab into the Amazon instance that was created. This is what we want to see for our demo. We'll be able to get more details now by refreshing this page. We should be able to see the status of the different L3 VPN BGP peers. So we can now see that both of our peers are up, and we also have our status on the active prefixes both at 3. This is exactly what we want to see, and our ping is working. So this completes everything we wanted to see for our demo. This concludes the OESS 2.0 demo of capabilities, including provisioning into AWS Direct Connect. For more details, please see https://globalknock.iu.edu for more details.